Okay. Can you hear?
Yes.
All right. So we'll start. We have a system and the system linear time invariant, LTI. The most important property we're focusing on is that this system is linear. What does it mean linear? It means I can use superposition. It means if I have a signal and I found the output, I have the second signal, I have the other output, I add them, I get the total output. That's the meaning of it. We'll start, we'll say it has an input, which is x of t, and the output is y of t. And the problem is, yes, you have question? If you look at the input as discrete, I'm going to start with discrete, not continuous, because the discrete will make you understand the concept, and then we'll go to the continuous next lecture. So let's say that you got input, and the input look like that. Well, actually, I can represent them as impulses with different magnitude. All right. So the question is, what is the output? So that's the question. To answer this question, convolution will help us. So you can say that convolution is a mathematical operation you are going to see now that represent a signal passing through a system, linear system, especially linear system, to find out. That's the convolution, yes.
So for the impulses, even though their amplitudes are different amounts,
yes,
are the areas still one for each one?
No. The impulse, unit impulse, the area is equal one. Unit. But yes, but when you say impulse, it can have different area. But what the property? The time duration is really very small, almost zero, and the magnitude or the area be one if unit or different. So that's a good question. So when you say unit impulse like that one, because it's very important to understand from the beginning the concept. If you write delta t, I'm sorry, I'm talking now discrete. If you write delta n, it means at zero, when n equals zero, the duration is really small, almost zero, and the amplitude is very high, but we can say that the integration will give you one, or you can say it's equal one. So you can say it's equal one. That's unit. But if you want to represent a sample which the height is equal 5 at n equal 3, we can do that. So we'll go and have something longer. And the height is equal 5, so I'll write 5, and at n equal 3, so you multiply it by delta n minus 3. Because if you write only 5, it means like 5, it's like continuous, 5 everywhere. No, you want 5 only at this position. So you say 5 delta n minus 3. Because delta n minus 3, it means everything is 0 except only at n equal 3. So that's how we represent one sample. So to find the output, they did something very interesting. They got the same system. And they put only one unit impulse at the end. At 0. So what is that? Delta n. And then they look at the output. They record it. Whatever they got at the output, they call it impulse response. Let's say, for example, we got something like that. Because it depends on the system. The system characteristic, it will give you different response. So let's say that you got something like that. It was like 2 at n equals 0. And then you got 1 and then you got half. And then zeros everywhere. So that's the output when the input is unit impulse. So what do you call that? When the input, when x of t, I'm sorry, I made a mistake, it's not x of t, we're talking discrete. X of n, and the output y of n. In this case, when x of n is equal to the unit impulse delta of n, the output y of n, we'll call it h of n, which is called in all textbook impulse response. And it makes sense, an impulse response, because the input is impulse, unit impulse. All right. Now I will go to the first example. We need to find the response of the input, something like that. Let me just fix, it's not x of t. We're talking discrete. First, let's make a test for this system. The question is, what about if I use something else, not unit step? Let's say I'm going to use the signal I just did before, which is equal to 5 delta n minus 3. And zeros everywhere. What I want to get. What do you expect? That's what you did the test. You put input, impulse, and that's the output. What about if you have impulse, but not unit? The height's 5 and shifted. So what do you think? What will happen to h of n? Yes. It's linear system. What? Will be what? No, why go back to zero? What? Why go back to zero?
Would it keep the time shift as it goes through?
It will keep the time shift. Like instead of h of n, it will be h of n minus 3. And instead of the amplitude, it will be multiplied by 5. Yes, that's good. So let's sketch it now. So what will happen here? Everything multiplied by 5 and shifted by 3. So instead of 0, will be shifted minus 3, so it'll be like delayed till to get to 3. So I'll say that, for example, that's 2, that's 0, 1, 2, that's 3, and then it was 2 multiplied by 5 will be 10. 10 delta n minus 3. And the next one, that was 1, will become at 4. 1 will be times 5, will be 5. And the other one was half times 5 will be 2.5. So actually, it is very simple. So we can say that if you have a signal and at any place, let's say that the value is equal x, let's say k, and it was at the position n minus k, of course. So that's the input. If the input go to the system, h will be the same n minus k and will be multiplied by the magnitude, exactly as I did here. Look at that, 5 multiplied by 5. And shifted, it will be shifted. So it's simple.
So, regardless of where we're located on the right side, with the 5 delta and 3, you're still going to have a 1, 4, or 1, 2, and 3 case. So
What do you mean 1 and 3 case?
what, how the LTI functioning to get 3 outputs for 1?
That's not 3 outputs, that's 1 output. It's 1 output from the beginning. I have 3 samples. That's the output. and the output in 3 samples, the same. It does not increase the samples.
So it just depends.
It just changes the shape and the magnitude. It's shifted in time, and the amplitude getting maybe higher or lower, but it keeps the same number of samples.
You have to predefine the sample before you word it from.
You have to find, you have to know first the unit impulse, the impulse response first to get anything. What about if you have 2 pulses as input? Like if you have this one, let me take example.
What does the LTI stand for again?
What?
The LTI, what does that stand for?
Linear time invariant. Okay, let's take one example. Let's say the input x of t. Let the input x of n. I always make this mistake. X of n given in this diagram. That's the x-axis, which is represent n. I will start from -2. The function was equal 0, or the signal 0, and after that it was 0.5, and at 0 it's equal 1. That's 1 is equal 2. At 2 is equal -1. At 3 is equal 0. At 4 is equal 0, and then 0 everywhere. That's x of n. X of n. How can I write expression for x of n? Very simple. We already know how to write expression for one sample, or for one sample only, like 5 delta n minus 3. You can write for each one and make it just sum. Let's start. We'll say x of n is equal to, you don't write the zeros. When the signal is equal 0, don't include in the expression. So you start with -1, so it means delta n, -1 or +1? +1, right? When you have shifted to the left, you say +1. Because if you put n plus 1 equals 0, n would be equal -1. What's the amplitude? 0.5. So that's the first one, right? Okay, the second one, how you write? All right, how you write the second one? At n equal 0. Just delta n, it's just unit. Delta n. Okay, take the third one. You have to say something. When n equal 2, how you write? What is the amplitude?
It would be
First, to write the amplitude.
okay.
No, the amplitude of the signal at n equal 2.
It,
Just look at the graph. What's the value?
it's -1.
Is -1. The amplitude and its location at n equal 2. So we write it delta n minus 2, right? Oh yes, that's right. I skipped one. I still can, by the way, I still can write it because it keeps position, but let's be in order. You're right. Plus at n equal 1, the value is equal to delta n minus 1. At n equal 2, it will be -1, the amplitude, and delta n minus 2. 3 0, 4 0, or don't write. If there's something has 1 or -1, you can write it down. But this is, I mean, how I write expression for the segment x of n. Easy. Now I want to find the response. To find the response, we have first to define h of n, the impulse response. You have expression only for the input. You need to find the output, which is yt. Find y of n. To find y of n, you need to know the impulse response, h of n. Let's take example for h of n. I will give h of n like that. It was 2 at n equals 0 and 1 is equal 1 and at 2 is equal half and then 0 everywhere. So that's h of n. When you see h of n means this is the impulse response. This is the output of the system when the input is unit impulse. Once you know h of n, so you can get the output. Let's express h of n in this way. H of n is equal to 1 half, and you put underline 2, it means that's where n equals 0. You tell me, can I do xn exhibition like this one, h of n? Yes, of course. If you like to write that, x of n equal, you have 0.5, the first element, 1, 2, -1, that's it, right? And then you put underline 1. That's where n equals 0. When you look at the signal, right? That's n equals 0, it's equal 1. You put, so you can do the expression like that simple. Yeah. But why did I write the expression of x of n in this way? Because I'm going to solve this problem using 3 different methods. The first method I'm going to use a formula. Let's see how the formula is going. It's very simple. You look at the expression that you write in this way, x of n, and you see the response of each impulse. For example, delta n minus 1. Delta n minus 1, the response will be h n plus 1, right? And then you multiply by 0.5 here, the input, you multiply 0.5 here. So that's the response for the first pulse. The second pulse, delta n, that's simple. Delta n, it just will give you hn. The third one, 2 delta n minus 1. 2 delta n minus 1. So you have h n minus 1, 2. So it's just simple. You replace every delta by h. What about that? Simple. What do I have? You still have the last one, minus 1 delta n minus 2. What is the response? Minus h n minus 2. And since the system is linear, I'm going to add all the outputs will be one output. So when you add, you can now write y of n is equal to 0.5 h 0.5 h n plus 1. And then the second one, h of n. The third, 2 h n minus 1. The fourth, minus h n minus 2. That will be the output. To sketch it, you got to translate every expression into signals like in this expression. If this is h of n, let me write here. If you have h of n given in this way, 2, 1, half. If you want to find h n plus 1, so what will happen? Everything will be shifted towards the left. What does it mean? It means like everything shifted by 1 unit towards the left because n plus 1 making like that. For example, if you have signal at n equals 0 and it's equal to, in this case, is not going to be delayed, no, it will be advanced. So it will appear at 1. Everything shifted by 1. Follow me? Yes, it would be something from -1. Yeah, that's right. So you write 2, 1 half. But where is your n equals 0 now? Exactly, that's right. Shifted it. Okay. And if you want to write other number, will be like zeros after that, but you don't have to. Well, let's find hn minus 1 will be shifted towards the right. So the one at 0 will be at 1, right? So how you write that? And by the way, 0 will have 0. There's nothing there because what was in a -1 is 0, so there's nothing there. So what happened? You write 2 1/2, and where is your n equal 0? So at 0, so you got to do some modification here. You got to say, to put in 0, it's nothing there. So you put 0 and put underline. Because I mean, it's moved. There is nothing at 0. If you want to do hn minus 2, it's shifted 2 units. So this number is going to move 2 units. So you are going to have 2 zeros, 2 1 1/2, and where is your n? Let me sketch for you n minus 2 to understand. That's h of n. That's h of n. H of n is like that. 0 1 2, and you got 2 here. You got 1, and you got half. That's h of n. You want to sketch h of n minus 2. So you're shifting 2 units. So that's 0. That's 1, 2, 3, 4, 5, 6. So what in 0, it will go to 2. So so 1 unit, second unit goes 2. So you put 2 here. And 1 was at 1, 1 and 2 is equal 3. And the other one, just next to the other, just shift everything by 2 units. So what do you have at 1? 0. At 0, 0. That's why I wrote here 2 zeros. Shifted 2 units to that, right? So you got all the responses here. All what's supposed to do, substitute by these values in the equation of y of n we just wrote. So let's just substitute y of n equal 0.5 times hn plus 1. So you multiply 0.5 times 2 1.5, I think like that. So you will do it and then you add it, but let's just do it in a table. So you'll not mess up or make any error. What do you mean table? I did table, I did some table, so I just organized my result. I did like n, I put n here. And I started from -1, and then 0, 1, 2, 3, 4, 5, so on. That's n. And I did like the first term. I have many terms I see here. That's the first term, the second term, the third, the fourth. So I wrote the first term, or you can, if you want to make in detail, you write 0.5 h n plus 1. And the second one was h of n. The third one, 2h n minus 1. And the last one, -1 h n minus 2. Well, the table is easy. First, to write the right index for n, you look for your h. H start from n equals 0, right? And then you want to go to see the limit to the left. So you see the maximum n plus what? N plus 1. 1 plus 1, it means you are going by 1. And you go to the n minus 2. you'll find that you got 2. So you can add 2 points to the right and 1 to the left. So that's why when I said -1. It starts from 0. I did -1. And when it ends at 2, you can end at 4. But I just put 5 and extra. But you don't have to. Just to make sure that I'm not missing anything. Now let's look for the worst one. The 0.5 HN plus 1. You already did it. HN plus 1, 2, 1/2. And remember, you have the n here at 0, n is equal 1. So you put 1, and you got 2 at -1. You got half, and nothing. You don't have information to the right. So what you'll do? Zeros. Let's go for h of n. H of n 2, 1/2, and start from 0. N equals 0. So at n equals 0, it's equal 2, and then 1/2, and the rest 0. Okay, let's go for 2hn minus 1. Hn minus 1, the 0 is 0, and anything before that will be 0. And I multiply, remember, you have to multiply by 2. So 2 times 2 is 4. 1 times 2 is 2. Half times 2 is 1, and there is zeros. The last item, the last term, -1 hn minus 2. I got, start from 0 is 0. I got 2 zeros. And I have n equal 1 is 0. That's n equal 0. And then n equal 2. That will be, because this is n equal 0, n equal 1, n equal 2. 2 times -1 is -2. And then 1 times -1 is -1. And half times -1 and -1/2. There is nothing there. As I told you, I have 5 as extra. You don't have to use it. It's just I did it just to make sure I'm not missing anything. But actually, when you calculate right, that's it. So then what you'll do? Add. Yes.
So on the 0.5H of 10.4, are you supposed to change those values too?
The first one?
Yeah.
Oh, yes. Yeah. We should. Of course. Thank you very much. So I didn't change it. Hn plus 1, let's go. 2 multiplied by half will be equal 1. Let me check. 2 and 2 at n minus 1. So will be 1. And 1 times half is equal half. And half times half is equal quarter. Right? Yeah. And the rest are zeros. Yes. Half, quarter. That's right. Thank you. Now we are done with each term. Go ahead and add them. Oh, I'm sorry. I don't add n. I add only the value 1 and 0 and 0 get 1. Let's change the color. You have 1. 2.5, 2.5. Quarter, 1, 4, 5 and quarter. Let's write this way. 2.5 and 5 quarter. Half. 2 minus 2 is 0. You got half. 1 and -1 is equal to 0. And the last one, -half. So that will be your output. So you can write now the output yn is equal 1, 2.5, 5 quarter, half, 0, -half. Of course, the rest will be 0. You got to make sure where is your n equals 0, the second element, the both line. But by the way, when you read textbook, there are 2 styles they use to define the n term. Some they put underline like that, and some they make an arrow like that. So when you say arrow or underline, it means the same thing. It means that's where n is equal 0. Because not usually it starts from the beginning. As you see, you have -1 in the beginning here. So that will be the output. And if you like to write expression for the output, yes, you can. Y of n expression is, that's n minus 1. I'm sorry, this is n equal -1, right? So how you write it? Write it delta n plus 1, and the magnitude is equal 1.
Would be H.
Pardon me?
Would it be H or delta?
H or delta?
For
Yeah, and, no, delta. Delta. No, I see what you mean. This is the whole thing is y output. But how you express one at location n is equal -1. Yeah. So it be 1 delta n plus 1. We're already done with the h's, That's 0.5. It's 0.5 hn plus 1. After substitution and adding, we have in the end 1, which is 1 delta. That's good question. Now, the second element, 2.5 at n equals 0. Write the delta n. The third one, 5.25 at n equal 1. So be n minus 1. Half at n equal 2, be n minus 2. 0, we don't write it. And then you got the last one at n equal 4 is equal minus half delta n minus 4. So that's the way you're going to write expression for the output in terms of impulses.
Dr. Gus,
Yes.
so the y of n is the output.
Is the output.
The h of n was like the modifier, or
Are you talking about this expression?
so?
That's the output, the response of the input that it looks like that. When the input x of n like that, that will be the output.
And the h of n transformed it.
Hn, it has many operations done on it, like one signal was shifted and amplified, another signal shifted and the value decreased, attenuated. So there are many operations happen to this h of n. Every pulse go to the system, it's affected by the response and then put it in the memory. The second one affected, put in the memory. In the end, they added all of it and got in the end response with the same number of samples. If you look at how many samples, 1, 2, 3, 4, 5, it's the same thing that you have. So that's the output. But what helps us to find the output? The impulse response. If just that the response of one impulse, it can help you to get the total output for all these pulses. And when you look for each pulse, like if you want to see the effect of each pulse, you will find you have one output. For example, 0.5 has one output, 0.5 hn plus 1. The second has one output. But when you add it, then you get the whole things together in one output. Yes. When you add them, of course, you find that there is effect of each shift. But every pulse has its own effect on the shift and the amplification. Every signal, every pulse by itself has its own effect on the output, or the output is affected by each one individually. But when you add it, you'll find, of course, I mean, the shifted and like when you look at this table, it continued the story. You'll find that this signal, it was attenuated by half, and this signal was doubled. So in the end, you'll find the resultant of both. And for every signal that shifted, you find the amplitude is different, and they are added in the end. So yes, the shift is obviously it affects the response of the system. Yes, and that's how you express the output. Yes.
This also be done in continuous waves.
No, continuous time signal. You are using here summation, but when you have a continuous, you are going to divide it in very small, because there is no sampling. So you are divided into samples that the distance is almost zero between each one. So the summation will be converted to integration. So when I explain the convolution with continuous time signal, I'm not going to use that sum. I'm going to use integral, and be another story, very involved. That's why I started with this one, because this one will give you the understand the concept. But the integration after, if you do that, then you will understand the integration. So actually, when you look at what did we do about, we did expression for the input. We said that x of n, each signal has x of k multiplied by its own impulse to define the location, right? And if you are adding them, so you make sum. And of course, in general, k can start from minus infinity, go up to plus infinity. So that's the expression for the input signal we just did. And then when we did the output, y of n, it's the same magnitude affect the output x of k, but delta n minus k, that is the corresponding response was hn minus k. So you multiply it by hn minus k, and you just make the summation from minus infinity to infinity. So actually, this is, I mean, the two general expression that we use, but I didn't like to write. I hate to write formula and then I tell you, well, let's apply that. No, it's better to deduce it. So that's what we did. So that's how you express the input and how you get the output, replace every delta by h. All right. There are other methods to find the response. Maybe you like. There's something by using a table called tabulation method. Remember, what's given in the problem, the input x, that's the input x, and the impulse response. And then we did the process with the summation. What about if there's an easy way to can do? Yes, there is an easy way. Let me take an example to show you how to make convolution sum using a tabulation method. But what we explain just right now, it just explain the main concept behind convolution. Let's say that you have x, example, x1 to 1. I'll take just simple one, 1 to 1. And let's say that's where is n. And the impulse response was given as 2, 1.5. And that's where is n equals. So how can we use a tabulation method to find out one? You make a table and you write here like your h2 1.5. Let's make it bigger so you can see it. 2 1.5, and that's h. And for x 1 to 1, you put it in the other. That's 1 2 1. And what we'll do, we're going to multiply. 1 times 2 is equal 2. 1 times 1 is equal 1. 1 times 0.5 is equal 0.5. Let's go for the second row. 2 times 2 is equal 4. 2 times 1 is equal 2. 2 times half is equal 1. The last one, 1 times 2 is 2, 1.5. Easy, right? Now, how we can find out? Let's use, red line here. So you go and start to make diagonal. The first element here, you make diagonal here, so you find you got 2. The second diagonal, you'll find yourself you have 1/4. The third diagonal, you got 0.522. And then you got another diagonal. So just, when you make it in a good table and you connect the diagonal, so that's the output. What do you mean that's the output? Well, this one, the first diagonal, you got it. That's the first response, y naught. So y naught is equal to. The second diagonal, you got 1/4. By the way, you are not including, of course, h or x. You are including the result, the multiplication. You got 1 and 4. You add and you get 5. So that's y1. y2, the third diagonal, y of 2. When you add 2 and 2, 4, 4.5. So it's equal 4.5. 1 and 1 is equal to. That's y of 3. And the last one, y4 is equal 0.5. So you got the output. You multiply, connect the diagonals, add the diagonals, and in order 0, 1, 2, 3, 4. So y of n, you can write it like that. Y of 0 is equal to, y of 1 is equal 5, y of 2 is equal 4.5, y of 3 is equal 2, y of 4 is equal 0.5. So that will be the answer. It didn't take time. Can you do the other method using the formula we did? Yes, you can. To do that,
How would you know where your 0 is on that?
how do I know the 0? Oh, where is, that's a good question. You look for n equals 0. How many elements behind? 1. And the n equals 0. How many elements behind? Nothing. So you add them, it'd be 1. Again, you look for how many elements behind n in each, and you add them. Like, for example, if your h was like that, just many numbers here, and the underline was here, and the input was like that, just let's say that the n was like here. So how many elements behind? 2. How many elements behind this one? 3. 2 and 3, 5 will be the fifth one. The output, the n equals 0 will be the fifth element. In our case, you have only 1 element and nothing here, so the be 1 element behind. Okay, let me show you another method, and then I will go back and prove this one. I will do the same example using multiplication. That's the third method. The same numbers. So you have, when you look at them, you have 1, 2, 1, and 2, 1.5. So just I'll put them in the top of each other to make multiplication. You have 1, 2, 1, and 2, 1.5. 2, 1.5. And then I'm going to multiply. But you multiply in a different way. I'll start from the right. 0.5 times 1 is equal 0.5. 0.5 times 2 is equal 1. 0.5 times 1 is 0.5. Then you go for the second one. When you go to the second one to multiply, you just put x on here. 1 times 1 is equal 1. 1 times 2 is equal 2. 1 times 1 is equal 1. Now I'm going to multiply 2 by the third, so you make 2 x's. 2 times 1 is equal 2. 2 times 2 is equal 4. 2 times 1 is equal 2. And then you add 0.5. 1 and 1 is equal 2. 2 and 2, 4, 4.5. 1 and 4 is equal 5, 2. So that would be the output. And the element is this, n minus 0 is the second one as we explained. Let's look at the result. 2, 5, 4, 1. Yes, the same. So you got now three methods. Formula, first one, table, tabulation, and the third one, multiplication. You got to know the three of them. Yeah. But when you ask the question and you have a choice, or choose the easy one that you like. Do you understand?
That third method didn't sink in.
Huh?
That third method did not sink in.
The third method?
The first two kind of make sense.
Yeah, the first one, it's actually it's like how they did it. But after that, people sit down to find how they make it in a simple way so they can get the answer quickly. So when you investigate something, you will use the first method that I did. But if you are asked just to want to find the answer, just use this one, because what I'm showing now, how the people work it out, how to get the same result without doing the whole thing they did. But the first method is very important, because if you have any new situation, you got to go back to it to do. But if you have normal situation like that, use anyone. Use the table, use multiplication.
Can you use a different, can you do multiplication on a different set?
Of course. You want an example?
A different example, please.
Okay. What about if I make it quiz, then I solve it?
Make it.
Quiz.
No, not the quiz yet.
Okay.
It's the quiz time already?
Yeah.
It's
a quiz time. All right.
Let's pick our message.
I will give you one quiz. Quickly one. Quick one. And easy.
Thanks, guys.
It is the reason.
30 minutes. Yeah. It's too early for a quiz.
No, it's not too early. So we can no. I'm not going to start the convolution integral, because it's it's very simple one.
You say that all the time. You say it every time. I have trust issues now.
So you have the input x of n is equal the unit step from n equals 0 to 4. You got the impulse response h of n is equal n. N change from 0 to 3 and 0 otherwise. It's required to find y of n. And by the way, how they write convolution? Y of n is equal x of n convoluted on h of n. That's how we write convolution. Use a star. Yeah. And that's the formula, the equivalent of this one, from k minus infinity to infinity, x of k and h n minus k. That's the formula. Anyway, you don't use in this quiz, just use any method you like.
Is that a U of it?
Yes, the unit step.
Unit step.
Unit step, you factors. All right. Let's just tell these guys online to do their time now. Takes 5 minutes max. So 118 plus 5, 123. You can see. Oh. You guys should, all of you get it right. All of you should get 10 in this one. And to make it simple, what does it mean x of n unit step from 0 to 4? It means that when you start, we start from n equals 0, 0, 1, 2, 3, 4, you have 1, 1, 1, 1, 1, and then the rest will be 0 everywhere. 1, 1, 1, 1, 1. That's it. This one is like ramp, but only for limited n. Also, I made it very easy, start from 0, not -1, -2. 1, 2, 3, up to 3. N. So when n equals 0, it is 0. When n equal 1, it's 1. When n equal 2 is 2. When n equal 3 is 3. This is exactly like the ramp function, the ramp segment right before. And the rest to be 0. So it's easy. So no, it's actually easier than the example. Unit step 1, 1, 1, 1.